Okay, number 5. Limit as x goes to infinity of e to the negative x times ln of x squared. Well, as x goes to infinity, the natural log function looks like this guy with its vertical asymptote along the y-axis. Sorry, again, that's too high. So you can't see that. But as x is going to infinity, the natural log function is also going to infinity. So this is infinity. E to the negative x is exponential decay. So exponential decay looks like this with the x-axis here. So as x is going to infinity, e to the negative x is going to 0. So this is 0 times infinity, which is one of our indeterminate forms. Okay, well, you can't apply L'Hopital's rule on a product. You have to apply L'Hopital's rule on a quotient. So you're going to need to take one of these factors and flip it. Sometimes it'll be obvious, sometimes you'll have to play with it. This one is maybe a little bit obvious what we should try because we have an e to the negative x. Negative exponents naturally flip terms down to the denominator anyways. So let's go ahead and flip our e to the negative x. So let's make this ln of x squared over e to the x. And again, we just did that because the negative power takes e to the x down to the denominator. Okay, now written in this form, as x goes to infinity, natural log squared is also going to infinity, and e to the x, which is now exponential growth, is also going to infinity. So we've got a quotient of an indeterminate form, infinity over infinity. So let's apply L'Hopital. So limit as x goes to infinity, take the derivative of the top, take the derivative of the bottom. Derivative of the top is going to require the chain rule. So the 2 pulls down, and then you don't touch the ln x, and the new power is 1. And then you've got to multiply by the derivative of the inside, which is 1 over x. Derivative of e to the x is just e to the x. So actually, what we get here, simplifying this before we try and direct substitute again, we get 2 ln x over, since this is held by multiplication, 1 over x just puts an x in the denominator. Okay. When we try again, what happens as x goes to infinity? Well, 2 ln x is also going to infinity. And x times e to the x, that's a huge number times a huge number, so that is also going to infinity. So we're going to try L'Hopital again. Limit as x goes to infinity. Okay, take the derivative of the top, take the derivative of the bottom. The derivative of the top now, just 2 ln x, so the 2 pulls through, and the derivative of ln x is just 1 over x. Derivative of the bottom, I see 2 x's. They're held together with multiplication, so you're going to need to use the product rule. First times derivative of the second, which is just e to the x, plus second times derivative of the first, but derivative of x is just 1. Okay, so let's see. Simplifying this, we get limit as x goes to infinity. Again, 1 over x, that just puts an x down in the denominator. So this x here is the 1 over x, that I put the x in the denominator. E to the x, e to the x plus e to the x, you could factor out an e to the x, and then you're just left with x plus 1. Okay, so what's happening in the numerator, you just have the constant number 2, so this is not going to be an indeterminate in form. In the denominator, you've got x is going to infinity. So x is big, e to the x is big, and x plus 1 is big. So this is 2 over a huge positive number, and 2 divided by a huge number is 0. So this limit is equal to 0.